Hello everyone, welcome to our PBL Level 1 Physics project. Today we're going to talk about conservation of momentum. And it's going to be a three-part investigation. In the first part, we're going to investigate the behavior of objects are having elastic collision. In the second part, we're going to investigate inelastic collision. And in the last part, we're going to investigate explosions, when we are going to have one object and then it explodes, and the behavior of momentum. And we're going to observe if we are conserving the momentum and what's happening. And we're going to discuss it in a couple of different cases. And now let's introduce our materials. For the experiment, we're going to have two motion sensors to be able to measure the velocities of the object. And if you do not have motion sensors, you can just have an investigation, and in this case they're just going to try to figure out the velocities. So if it's going faster, if it's going slower, so you're not going to be able to have a data. But if you want to have a numerical data, then you're going to need two motion sensors. And we're going to need two USB links to be able to connect our motion sensors to our computer. We're going to need two cards. And if you have two different colors, then that is going to be better, so that you can figure out which one is which one. And we're going to need masses. And I have 4. If you want to have more combinations, then you can have more. Or if you want to have less combination, then you can have less. And last but not least, we're going to need a track. And of course, we're going to need a software to be able to run the program if you are using a motion sensor. All right, let's see the setup. We're going to have two motion sensors, and then we're going to mount them to both ends. And that motion sensor is Pasco's motion sensor and Pasco's track. So you can mount it perfectly. So there's a hole over here, and that is perfectly fitting with the track. So if you find it correct, then it should be able to push in. And as you can see right now, it is set over here. And then we're going to connect the other motions to the other end. Now we're going to connect our USB links to the computer. And here is our USB ports. And once you plug it in, you make sure that you see that green light. And then the other one. And we're going to see those two. And now, after you connect your USB links to the computer, you can connect your motion sensors to the USB links. And that perfectly fits in. And the other one too. All right, now our motion sensors are ready. What we're going to do next is we're just going to place the cards on the track. Now we're going to place our cards on the track. And these are Pasco's cards, and one end you're going to have that sticking part, and on the other side you're going to have magnets. So for an elastic collision, we're going to face two magnet sides to each other, and then we're going to place one of them somewhere in the middle, and then we're going to place the other cards like 10 centimeters away, 5 centimeters away from the motion sensor. And that is going to be our setup. And now, this is basically the setup of the collision experiment. And what we're going to investigate over here, we're going to observe the collision, the type of collisions, what happens if it's an elastic collision, what happens if they have the same masses. So they're just going to make an observation, and if you want, they can also calculate data, which I am going to do. But if you do not have sensors, then you can just do the investigation, and then you can get your kids draw the vectors and showing that what happens to the motion of that, and then you can get them predict the graphs of those two cards. And I am also going to investigate by adding more masses. So what happens if the card that is at rest is the stationary card that has more mass, what's going to happen if it's an elastic collision? What happens if you switch the masses? All right. So we're just going to make the observations, and then we're also going to see if the momentum is actually conserved. All right. So in the first part, we're going to start with one at rest, and the other card is going to have some momentum at the beginning. So we're going to press one of them, push one of them a little bit, and then that's going to be going with some velocity. And then we're going to see what happens if they collide. All right, again, you can start with the prediction of their graphs, and then you can get them conduct the experiment, or if you have motion sensors, then you can collect data and you can calculate and you can see if momentum is actually conserved. All right, let's start the experiment, but before we start the experiment, let me explain how is going to be the setup of your sensors. All right, we're going to need our software, and I'm going to use Passcode Capstone. And I have two motion sensors that I'm going to need to observe the velocities and the motions of those two cards in both graphs. So I'm going to need two graphs on the same screen, and for this you go to the graph and you click on it, you hold on to it, and then whenever you move it around the screen, you're going to see that on the right corner in the center, right side on the center, when you place it over there, it's going to shade half of the screen. So whenever you leave it there, you're going to have your graph over there. And then for the second graph, to be able to put it over here, you go to the graph icon again, you click on it, hold on to it, and then you drag it to the other pages, half pages center, and then it's going to shade the entire half screen. Then whenever you leave it there, you're going to have your two of the graphs. And now we're going to need velocity time graphs of those two cards, since we're going to measure their velocities. Or you can ask your students what graph they're going to need, since they're going to be talking about conservation of momentum, and momentum is about mass and velocity. They should say that they're going to need velocity graphs. All right, and I'm going to have two of the velocity options over here. So as you can see, channel A and channel B, and over here, channel A is one of the motion sensor and channel B is the other motion sensor. I don't know which one is which one, but I can simply figure it out. For example, I'll just choose channel A, and this is my velocity, and whenever I start collecting data, I'll just put my hand over here. As you can see, it doesn't really affect, and that means my channel A is for this guy. As you can see, you are able to connect, you're able to see the motion of that guy. So that means, and I can delete that data. So my channel A is the one on the left. So the blue card is measured by channel A. And on the other side, I'm going to choose channel B, and I'm going to need the velocity of that. And if you want to make sure that you can try it again. All right, now everything is ready. I'm going to be measuring velocity of the blue card on the left graph, and I'm going to be measuring the velocity on the right graph of the red card. And in the first part, I'm just going to start with the same masses. So it's up to you. You can ask your students to try any masses with any speeds that they want, or you can instruct them to do certain collisions. All right. And I'm going to have three different types of collisions with different masses. First, it's going to start with the same masses. All right. And what I'm going to do is I'm going to collect data. I'm going to record it. And then I'm just going to push this car on the left. And make sure that you do not push it too fast or too slow. And then we will just observe their motion graphs. All right. So I'm ready. Let's get started. Record it. So make sure that they both measure 0, and I'm going to push my cart on the left. And you are going to stop it right before it hits to the motion sensor. All right, right now I am going to enlarge that graph it seems like there's something over here, but you can't really see what's happening. So I am going to enlarge the screen. So for this, you go to the left hand and you can make this a little bit smaller, and that's what you're going to see. And for this side, again, let's enlarge it, and then let's drag them over here. And let's drag this guy over here too. All right, so due to the conservation of momentum, since there is no force in the system, momentum should be conserved. So momentum before the collision must be equal to the momentum after the collision. All right, now I have my example table over here. This is going to be elastic collision, and I'm going to investigate before and after collision. So before the collision, I'm going to have two masses. I'm going to call mass 1 my blue cart on the left, and both of my carts are 250 grams, so that is going to be 0.25 kilograms. And I do not change my mass, so before and after, my mass is going to be the same for both of the carts. And now we need to investigate the velocities. And at the beginning, so let's go to our graph. All right, let's see our graph. So that is showing that this is the blue car and this is my red cart. And over here, I am seeing that when the time was 7 seconds, I started to push it. Until 7 seconds, it was at rest, and at 7 seconds, I hit it. And then it gained some velocity, and then it dropped to 0. And when it's dropping to 0, around 8. So this is my blue cart, and blue cart was the one that is moving and stopping. And let's see what's happening over here. If you want to investigate the velocity of this guy, as you can see, when this is stopping, this is starting to move. So basically that part is when they are interacting. So basically this is my velocity for the blue cart, for the first cart. This is my velocity before the collision. So I need this velocity. And I am just going to need actually 1 point. And for this, I'm going to need a coordinate tool. So I am going to come over here because this is my velocity right before it hits. So my velocity right before it hits is 0.40. So I'm going to come over here and I'm going to record over here, 0.4. And my velocity of the second object, which is the red cart, and that is when this guy is starting to move. And before they collide, my velocity of the second cart is 0 because it's at rest. So velocity of the second cart is 0. All right, let's see the velocity of the first cart after the collision. So as you can see, this is your velocity after the collision. So what are we going to do? We're just going to bring it over here. And as you can see, your velocity is 0 meters per second. And that's actually what happened. So my first cart stopped and my second cart moved. And let's see the velocity of the second cart. So this part is before it hits. So I'm going to look at this data because that is right after it is done with like interacting, and then this is the velocity right after. So I'm going to use my delta tool again, or coordinate tool, and add this one, and let's go and see what is your velocity right after. So as you can see, your velocity right after is measuring. That's negative, and that's because of the motion sensor setup. Because motion sensor is measuring negative if it's coming closer to the motion sensor, it's measuring positive if it's going away. So this is the reason why it's negative. You can make it positive, but I'm not going to do that. All right, so that is basically 0.41. So 0.41. So as you can see, your initial momentum over here is 0.25 times 0.4 plus 0.25 times 0. And that is your final velocity. So let's find our P initial. and P final. And what's my P initial? Basically, let's have equal. I'm going to multiply. I'm going to find the momentum of the first car. So that is mass of it times velocity of it plus mass of the second car times velocity of the second car. So just in case, let's take that into parentheses so that it's not going to have any problem with the math part of it. So my initial momentum is 0.1 kilograms meters per second. And what's my final momentum? Then again, I am going to multiply my initial and final values. I'm going to multiply mass and velocity of the first object and mass and the velocity of the second object after the collision. So parentheses, mass times velocity, close the parentheses, plus mass, mass plus, maybe not plus, maybe multiply. So as you can see, momentum before is 0.1 and momentum after is 0.1025. And let's get the difference, delta P, and that is going to be final, equal sign first, final minus initial. So as you can see, momentum difference is a little bit, 0.0025, and this is pretty small. And actually we can say that momentum before the collision is equal to momentum after the collision. All right. So now we are going to, and over here you can discuss the reason that momentum differences. So what can be the reason for that difference? And you can investigate that part as well. And I'm going to move to the next part. And over here, I'm going to have heavier object that is at rest. And I'm going to have another object that is going to hit to that. All right. And let's see what's going to happen now. So I'm done with this data, and I'm going to delete that data, and I'm going to start my own. So the car at rest is 500 grams right now, which is twice of the mass of this guy. And the scenario is the same. I'm going to hit this guy. I'm going to push it a little bit. So it's going to hit it, and then let's see what's going to happen. All right, let's record it. And my blue is, the one on the left is measuring my velocity of the blue car. And let's start. So now, this is basically when I pushed it and it reaches to a certain velocity and it's going with constant, I would say, constant velocity. And then its velocity is changing its direction. It was going in a positive direction and it started to go in the negative direction. So that is the velocity before and that is your velocity after. And for this guy, it was at rest. And after the collision, it started to have a positive velocity and it's going into the right. So it seems negative, but that is because of the motion sensor setup. All right, and let's see what we have over here. So I am going to need that coordinate tool again, and I'm going to bring it to here. And that is my velocity right before the collision. So my velocity right before the collision is 0.49. So let's copy this and paste and copy this. Whoopsie, we do not have, hold on. Yes, we do not have that. So my mass of the second is going to be 0.5 this time. So my mass is 0.25 and my mass is 0.5. All All right, so these are my values. And my velocity before the collision for the first mass is 0.49. And my velocity for the second object is 0. And then my velocity after the collision. So this is the part where we have the after the collision. Let me put a border for those. So we're going to know which part is which part. So now we're going to move to the after the collision part. So let's see our velocity after the collision. So if I drag it over here, so that's your velocity right after the collision. And that is negative. That's important because momentum is a vector quantity. So your momentum is going to be negative 0.15. So that is negative 0.15. And let's see what is our velocity of the card, second card, after the collision. And I'm going to need that coordinate tool again. And I'm assuming that, well, hard to pick, but there's a slight difference, so I'm going to pick that one. So 0.32. And this is positive because, well, it seems negative, but that's because of the orientation of the motion sensor. All right, now, so if you hold it over here and bring it down, that is going to measure your momentum before the collision. And if you, so my momentum before the collision is 0.1225. And then my velocity, my momentum after the collision is exact same. As you can see, my momentum after the collision and before the collision is exactly same. So that means my momentum during the collision is going to be conserved. But what is the condition for that? You shouldn't have any external force during the interaction. And if there's an external force, then that's going to be the impulse, but we do not have any impulse in the system, so my momentum is going to be conserved. All right, so in the next part, I'm going to try a little bit different. I am going to have one heavy object and one light object, and I'm going to be like pushing those two to each other, and then let's see what kind of interaction we're going to see. And I'll try to push one of them a little bit slower to see what we have. All right, let's delete this one again, and let's record and make sure that it is measuring the right values. All right, ready, set. So that is my first cart motion, and this is my second cart motion. Let's make it a little bit larger. All right, now, and I move them at the same time this time. And again, you have to be careful over here. The second graph is measuring. So this second graph, positive and negative will be reversed because of the orientation of the motion sensor. So whenever I see positive, that means it's going in a negative direction, and whenever I see negative over here, that means it's going in a positive direction. So you have to be careful with that. All right, and let's analyze our data. Again, coordinate tool, and this is my velocity before. And on the left card, on the blue card, I have two masses. So the mass of this guy is 750 grams. So my card is 0.75. And my second card has one mass, so that means its mass is 0.50. So let's copy this to here. All right, now let's see the velocities. So velocity of the first card before they collide is 0.25. So 0.25. And what is the velocity of the second card before the collision? And I am going to put it right here. And its velocity is 0.26, but this is going to the left. And over here is positive, but we know that it's because of the motion sensor. So it's going to be negative 0.26. Negative 0.26. And let's analyze the data right after the collision. So I'll pick this one. So my velocity after the collision is again negative 0.15. So that is the first cart, negative 0.15. And let's see the second cart after they collide. Move it over here. So the velocity of the second cart is twice the first one. Well, we don't really have an exact relationship over here because I just randomly throw them like through each other. So over here, it's negative 0.33, but it started to move to the positive direction. So make sure that you change that one to positive. So positive 0.33. So 0.33, that is my velocity for the second car. And what I'm going to do now, I am going to bring it down, and that is going to measure my momentum before the collision. So that is my initial momentum. So initial momentum is that much, and then let's see what's my final momentum. And as you can see, there's a little bit of difference this time. And let's see, what is that difference? So as you can see, it is 0.005. So the final momentum is a little bit less, but we can assume that my momentum is conserved in all of the elastic collisions. But of course, with the students, you can discuss, because there can be a lot of different type of collisions in the system. But I just tried 3 of them. But in all of the cases, I have seen that the momentum is conserved. So what you can try with your kids, or what you might ask them to observe, is the behavior of an elastic collision. So because after the collision, they are not sticking together, they are bouncing and then moving back. Or not necessarily, but basically there's a bounce over here. And since this is an elastic collision, kinetic energy is also conserved. So if you want, you can ask your students to do the conservation of energy part, but I am not going to do this right now. All right, now in the next investigation, we're going to move to the inelastic collisions, but perfectly inelastic collisions. So for this part, what we need to do is we need to turn the direction of the carts, and then they're going to have that sticking part together. So once they collide, they're going to be able to stick together, and then they're going to move together. All right, so that is going to be the second part of the investigation. Again, my blue card is going to be left, and my red card is going to be in the center. And what we're going to do is, again, I'm going to have different scenarios, and then we will try to see how they behave. All right, in the first part, when it was an elastic collision, when one of them is at rest and the other car is moving towards to the car that is at rest, second car was gaining the velocity of the first, and it was stopping, all right, when it was at rest, of course. And let's see what's going to happen when you have perfectly inelastic collisions. And again, you can ask your students to have certain collisions, or you can ask your students and try different scenarios and ask them to see if the momentum is conserved during that collision. And I'm going to be moving this guy. I'm going to push this guy, and that has twice, actually 3 times mass of the first cart. And let's see what we're going to have. And let's record it and make sure that everything is measured fine. All right, I'm going to throw those to each other, and let's see what's going to happen. All right, let's see what we have over here. All right, let's enlarge the data a little bit more so that we can see it more clear. All right, so these are my datas. So that's my first cart, and this is my second cart. And as you can see, there is a little bit like a different collision over here. So that is the initial velocity of my first cart, and this is my final velocity of the second cart. And this is, first cart, and this is initial velocity of the second cart, and this is my final velocity of the second cart. So what we're going to do is, we're just going to record the values, but before that, let's look at the masses. My first mass is 0.25, and my second is 0.75. Copy this, paste it over here. Okay, so let's use our coordinate tool. So velocity of the first cart before they collide is 0.42. So 0.42. And velocity of the second cart before they collide is, so I'm going to get always this last point because that's right before they collide, and that is 0.6. So that is my velocity before they collide, so that's 0.6. However, it is positive, but it is going in the negative direction, so don't forget to have that negative 0.6. 0.69. There you go. All right, and let's see our final velocities. So your final velocity for the first cart is negative 0.36. So negative 0.36. And then let's move. And this is my velocity for the second cart after they collide. Well, obviously it doesn't measure the same. But I think this point is going to be a better point because they stick together, so they can have different velocities. So it's better to have better data. And over here, it is going to have 0.33. And over here, there's a little bit difference, and I think that's because of the interaction. So that is its constant speed. So 0.33 is a better answer. So negative 0.33. And since they're going in the same direction and they're going together, negative 0.33. All right, now we have all of the data, and let's pull it down. So my momentum before they collide is negative this time. So my total momentum before they collide is going to the left. And let's see, what's your momentum after they collide? It is 0.33, and let's see the difference. Again, 0.015, so there's a little bit of difference, and your final momentum is a little bit higher than your initial momentum. And in this case, what we need to observe over here, so when initial momentum is positive, then your final momentum is also positive. And when initial momentum is negative, which means total momentum is going in the negative direction, your final momentum is also going in the negative direction. And the difference is still almost zero. And let's see a different scenario for the last part again, for an inelastic collision. And let's see what's going to happen. So this time I'm going to switch. So I'm going to triple the mass. And this guy is going to be stationary. And let's see what's going to happen. All right, let's record. All right, so let's analyze the data. Let's enlarge it a little bit right here. All right, so delta. So that's your velocity before you hit, before they collide. And that's for the first cart. And what's my mass for the first cart? It has 2 extra masses, so that is 0.75. And what's its velocity? It is 0.33. And let's see the velocity of the first cart before they collide it is the mass of the first card is 0.25, and the velocity of this guy is 0. That was at rest. And let's see, 0.75 again, and 0.25. Okay, so now let's see the velocity of them right after they collide. So that tells it is still going in a positive direction, and it is 0.25. So 0.25, and we expect this guy to be the same because they stick together and then they move together. So as you can see, this guy is also 0.25. All right, let's see the initial momentum. That is your initial momentum, and let's see the final momentum. And let's see the difference. And as you can see, the difference is, again, pretty small. So we are assuming that momentum of a closed system is conserved if there is no extra force in the system. All right? All right, for the last part, we're going to have an explosion. So this time, we're just going to face the sticky end to the magnet ends. And then we're going to have the spring end over here. So whenever, and there's a button over here, so whenever you push on it, it is going to basically throw it away. So now what we're going to do is, well, this part, me doing this alone, is going to be a little bit difficult for me. But what I'm going to do is I'm going to put my masses over here. If you want, you can ask your student to do this too. Or if you have a longer track, you can try this at a longer track, because when I press it, they're just going to explode. So they're going to be pushing each other with really fast. So I'm not going to be able to stop them at the same time and stop the recording. So I'm going to put those masses, but I just need to make sure that motion sensors are not having problem with those masses. So motion sensors are pretty okay with that, with those masses, because they're not on the way. So I'm okay with them. All right, so what I'm going to do now is I am going to press this guy, and then we're going to observe the momentum over here. All right, to be able to hit, you're going to need something like hard, and then you can hit it like right from the top, and then it's not going to change any data. So let's see. That's kind of tough. All right, let's start. All right, 3 sec, go. Whoopsie. All right, everything's okay. Nothing's broken. All right, let's see the data. All right, over here, we're going to have, we need to describe the case this time carefully, because most of the time students are having a problem with the initial and final condition. So what's my initial condition, what's my final condition? So initially, they both are at rest before they are colliding, before they are having an interaction, before they explodes, both of them are at rest. So my momentum before they collide, before the explosion, is basically 0. So my masses is going to be 0.25, 0, 0.25, and 0. So that's my initial condition, all right? And my mass is still 0.25, and my mass is still 0.25. And let's see the velocities after they interact. All right, and I'm just going to take the average of this guy. So for this, I'm going to need a highlighter. So I need to highlight this area only. And I'm going to need the average of those points. And for this, I need my that tool that is going to give me the mean. So my average velocity is 0.84. All right, so my velocity after they collide is negative. That's negative value because it's going to the left. It's negative 0.84. So that is negative 0.84. And let's see what's your velocity for the second guy after they collide. All right, I think I'll just take this data over here. Okay, let's see. Or should I take the average? All right, I'll just take that one. All right, I'll take the average for this one too. So I don't need that tool. Delete that tool, and I'm going to need the average of this point. There you go. And as you can see, your average velocity after they collide, after they explode, is also 0.84. But this negative, remember that this negative is going to be positive because of the motion sensor setup. So that is going to be 0.84. And let's drop them all together. And let's see what we have. So your initial momentum is 0, your final momentum is 0, and your momentum difference is 0. So that's an explosion case, but your momentum is still conserved. So over here, one is going to the left, the other is going to the right, and they're going with the same velocities since they have the same masses. And now I'm going to change the condition a little bit. I'm going to add some masses to one of them, and let's see what's going to change. All right, now it's ready. Now we're going to have 2 masses on the right side, so that's going to be 3 times of the first car's mass. And let's see what's going to happen. All right, let's get the data. Let's record it and make sure that it is not doing anything wrong. All right, everything is okay. And let's see what we have. All right, now we had different masses, and let's see what we have this time. So I'm going to need the average of this part, those 3 datas, and velocity of this guy. Now it went to the left direction, so that is going to be negative 1.07. And initial case, hold on. So before they collide, initially they had both 0. First card has 0.25. And second card has 0.75. So its mass is still 0.25, and velocity is negative 1.07. And mass is 0.75 again. And let's see the velocity of this guy after they collide. And let's see those data. And what is my average velocity after they explode? It is negative, but again, that's because of the sensor setup, and that's going to be 0.35. 0.35. And let's drop them all down, and that is going to measure initial, final, and difference in the momentum. And as you can see, initially you have 0 momentum, and finally you have 0.005 momentum, and the difference is basically 0.005. And as you can see, this is also pretty small number. And if we check all of our data, we can conclude that if you do not have any extra force other than the internal forces in the system, then you do not change your momentum. Your momentum before the collision is equal to the momentum after the collision. So if you look at all of our data, momentum differences is always almost 0. Okay? So basically this is our investigation. And then we are concluding that momentum is conserved in an isolated closed system. All right, we did our investigation in 3 parts, and let's see what science practices that we have covered in this experiment. Students can justify the selection of the kind of data needed to answer a particular scientific question. So my question was, do momentum conserve during a collision? So, and to be able to answer that question, students decided which data they needed to collect, and they decided to collect masses of the cars before they collide, and the velocities of the cars before they collide, and mass and velocities of those two cars after they collide. And they figured out the answer. The next, students can design a plan for collecting data to answer a particular scientific question. Our question is still the same. Now they needed to decide what is going to be the setup. So they have decided to put 2 cards in front of each other, and then they decided to collide them. And depending on what type, they decided to face the right faces of those 2 cards. And the next, students can collect data to answer a particular scientific question. After they design what to do and conduct the experiment, they have collected the data of masses of the cards and the velocities of the cards from our graphs. And the last one, students can analyze data to identify patterns or relationships. After they did all of the investigations in all of the 3 parts, elastic, perfectly inelastic, and explosion type of collisions, they were able to figure out the patterns, like what's happening, what is happening to the velocities, and how do they move. So they were able to figure out the relationships after they conducted the experiments. So that's it for today, and thank you for watching, and see you next time.